Hello everyone. In the previous video, we saw three versions as to how to find out if a number is prime or not. And so version 1 was just 2 to n minus 1, you check if it's a divisor. Version 2, we just checked for 2 and then we checked the remaining odd numbers till n minus 1. In version 3, we checked only till the square root of n for the odd numbers and the even numbers remain 2. Now the thing is we need to test if we actually to check the actual time each thing takes, we need to include time.h, which has clock, so that we can run each of the three things for all numbers from 3 to 10,000, measure the clock difference. So for that, we need a start clock and the end clock to measure, and then we can use the difference to find out how much time each version is taking. So that's why I'm using V1 start, V1 end, V2 start, V2 end, V3 start, and V3 end. And we will actually find out if our hypothesis, which was that V3 is much faster than V1 and V2, we will find out if it's actually true. It might not be true. And so, yeah, before we use V1, I'm measuring the time as V1 start, and then I'm measuring the time as V1 end after all of that is done. And the same goes for V2 and V3. Finally, I would subtract V1 end minus V1 start, V2 end minus V2 start, V3 end minus V3 start, and I will print the same. Now, if you see carefully, V1 start, V1 end, etc. are all clock variables. So what you would get is actually the number of clock cycles, but we won't get the same in terms of actual time units or seconds. So that's why I named it as double V1 clocks. It's the clock cycles that in C that I will get as the difference. And the same would go for V2 clocks and V3 clocks. If I have to actually convert it to seconds, there is a provision in time.h where you can just write clocks per second, and it will give you how many clocks are there for 1 second. So if you divide V1 clocks divided by the clocks per second, we would get the exact amount of time in seconds that V1 took to execute that piece of code, and so on. And then I would write the code to, calculate the time in seconds so that it's much more intuitive for us to see. So that's why I write V1 seconds. I would just write it as V1 clocks divided by, as I said, clocks per second. And then, of course, I would finally print it. The same I have to be doing for V2 and V3, which is what I'm doing. The clocks per second value is usually set to 1 million in C, and it has nothing to do with the CPU cycles of the machine you're executing it on. We want to how many cycles and how many seconds. And of course, I should pass V1 clocks and V1 seconds here. And the same thing I should copy paste for V2 and V3. I copied an extra line, so I had to delete it off. I mean, it doesn't make a difference, but it looks neater. Inside the printf, I can still have V1. It will not, but could be an incorrect statement. So now let's compile this and run it to see what we get for 10,000. I'm using .exe because in a Windows machine, you would execute only a .exe file. As you can see, okay, I mean, it doesn't look neat without the \n. So let me just add \n real quick. I'll clear the screen so that the outputs look better. You can see V1 took 12 cycles, which is 0.012 seconds, but V2 took 606 cycles, whereas V3 took only 5 cycles. That's a huge improvement. Like, that's like 200x. That's exactly what we had predicted. Now let's try for bigger numbers. Instead of 10,000, I made it 1 lakh. You can see again that V1 took 957 cycles, V2 took 581 cycles, but V3 took only 0 cycles. This could be wrong. I mean, depends on various other factors. So it's better to do it multiple times and use the average to infer any results. That's why now I'm going to try for 1 million. You can see it's taking a long time. It will take, I think, a minute or something. I will fast forward this. Finally, we got the results. Wow. 80 seconds, 48 seconds, 0.09 seconds. That's insane.